So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.
So welcome to this week's Energy Show. We're in the middle of the winter season. It's not only snowing in much of the country, but we're getting dumped on with rain here in California. Now, it's a really good thing. It may be the end of the drought. This morning, driving in the downpour, I heard that the reservoirs have filled up, and Lake Tahoe is 1 foot over its normal limit. So we got plenty of water, surface water, and now we just have to make sure we can replenish that groundwater. But storms, like these rainstorms and snowstorms, are the biggest contributors to power failures around the country. We're even more dependent on electricity now. You build a new house, they don't have fireplaces anymore. Those are restricted in many places. In California, you aren't even allowed to use a wood fireplace on many days during the year. New construction bans some of them. And furnaces, if you have a gas furnace, yeah, you might have gas, but you need electricity to get that gas fan to work and to get the gas to turn on. You may even need electricity to heat your hot water, even if you have a gas hot water heater, because the ignition system's powered by electricity. And you can't be without your cell phones, your TVs, and your Wi-Fis if there's a power failure. So it's important. So there's lots and lots of interest in backup power. Now, I've been installing solar for a real long time, and many people make the logical assumption that if it's sunny out, but there's no power, you'd still be able to get power in your house if you have a rooftop solar system. Well, unfortunately, the answer is no. The reason is that the inverters, which convert the DC power from the solar panels into AC power in your house, these inverters only operate if they see grid reference power. And the reason for that is if there's a power failure, no power on the grid, when your solar system's running and your inverters are running, your system is going to actually be backfeeding the grid, which could be dangerous to any utility worker using the system. It would also just probably burn out your inverter. So all systems are UL listed and designed to make sure that if there's a loss of grid power, the inverters shut down. Now, you can get special battery backup or backup power systems that use inverters that operate like that, but that's not the normal inverter that we all see. Now, some inverters, SMA makes a pretty good one, that can power small devices if the power is out, as long as the sun is shining. So there's a little outlet that you can attach to this inverter, and you can get maybe 100, 200, 500, maybe even 1,000 watts if it's really sunny. It's enough to power an appliance, a cell phone, but it's not going to power your whole house. For that, you need a backup power system. And there's two options for backup power systems. One option is a generator, and the other option is some kind of battery backup system. In a nutshell, the generators are good if you need a lot of power or if you want to get an inexpensive system. Solar with battery backup, very cool, very electronic, no moving parts, but it's still on the pricey side and it has relatively low power output. So may not make sense for most people right now, but I expect that's going to change. So we're going to talk first about the power needs that you require if you have a blackout. And this is the information you're going to need to figure out how big a generator put in or how big a battery backup system to put in. Now, typical modern house has an electrical service panel. That's where the power comes in near your meter. That panel has a capacity of 200 amps. Older houses may have 100 amp service, but new houses typically have 200 amps at 240 volts. So 200 times 240 is 48,000 watts. That's a heck of a lot of power. And you need a pretty good sized motor to run that. Now, it's kind of interesting. I compare it. My Chevy Volt draws a bit over 100,000 watts because I can see it on the tachometer, I guess, the power meter, when I floor it. And that's a 134 horsepower motor. So 746 watts in horsepower, 48,000 watts is a lot of power. Now, but in your house, usually, 95% of the time, you're using a fraction of the total capacity of your system. You're not using 48,000 watts. You go broke paying for electricity at 48,000 watts. I kind of did the quick numbers here. In California, you'd be looking at electric bills that are probably $5,000 or $6,000 if you use that much power. Normally, during the day or in the evening, when you're home, you may be using 10,000 watts or 20,000 watts when things are active. And that's because you have to look at what your appliances are drawing. So all those little plug-in chargers, I call them vampire loads, clocks, gadgets, chargers, things like that, they each use about 3 or 4 or 5 watts. Your lights, your appliances, your TV, and your stereo, each of those things will use between 50 and 100 watts if you have ordinary incandescents. LEDs obviously less. Now, anything with a motor, that's the way I kind of think about it. A fridge, a dishwasher, a washing machine, the fan in your furnace. Those motors use about 500 watts when they're running. Now, looking at things that use more, a microwave, 1,000 watts, hair dryers, 1,000 watts. And that's kind of stuff that you plug in. Now, if you go beyond that, the electric dryer in your house, it probably uses 10,000 watts. If you have an electric stove, 5,000 to 10,000, maybe even more than that watts. And that depends on how many burners you're running at once. Each one of those burners uses about 1,000 watts. The big one might be 2,000. The oven might be 5. Now, air conditioner. You have a big air conditioner. Each one of those compressor units, maybe about 10,000 watts. So luckily, you never use everything at once. I mean, you're not going to be running your electric dryer, your air conditioner, your stove, your microwave, your hair dryer, and everything at once. You're going to use them at a certain time. So you don't need 40,000 watts of backup power. It's much cheaper to install a smaller system. So when you're looking at these things, there's two strategies for putting these backup power systems in place. One strategy is to say, the heck with it. I'm just going to power the whole house with backup power system. And the other way is to use a smaller system, and it's only going to power the critical load. And sometimes we call that a critical load subpanel. Now, so let's look at the kind of the no-brainer easy option, which is just whole house backup power. And in that case, you can say, gee, I might need 20,000, 30,000 watts or so. I'm going to be kind of careful about what I'm running. I'm just going to put in a big system that's going to run the whole house. And that's kind of an easy no-brainer strategy, but it's going to be expensive. So if you're going to power the whole house, you're going to need a generator that puts out, I'd say, 15,000, 20,000 watts. Now, that 15 or 20,000 watt generator is going to be plenty as long as you're not running your air conditioners and your electric stove and your electric dryer at the same time. Now, you probably can run one of those things. Hey, I got to do a load of laundry. I got to run my dryer. There's a blackout. I got a 15,000 watt generator. That's fine. Just make sure that you don't start cooking a big meal in the oven on the top of the stove on your electric stove. Otherwise, you're going to kind of stress the system out. Now, you can get a monster home generator, 40,000 watt generator. That's good for anything and everything, but it's going to be more expensive. It's going to use a lot of natural gas, and it's going to use more energy when it's going to run. So what I would suggest is look for a way to put a smaller generator in, 10, 15,000, 20,000 watts, so that you can just power part of the house. Don't be a pig. You don't have to power the whole thing, just like there was no blackout at all. Now, the other option is to install a critical loads backup power system. So you put in an extra electrical panel to which only the most important appliances are connected. Electricians do this all the time. It's called a critical load subpanel. It's a little subpanel that has some separate circuit breakers on it, maybe 6 circuit breakers. And these circuit breakers would control the important things in life, your necessities, things like your television, your Wi-Fi, your cell phone charger. This is what they needed on Gilligan's Island. They're really the necessities of life. Now, obviously, you're going to use one or two of these circuit breakers for your heating system. Now, to people, that's even more of a necessity. So it's going to run your furnace and your thermostat. It's going to run your the electrical control and your hot water heater. It's going to run some lights. Maybe you want it to run, something in the kitchen. Maybe a few outlets in the kitchen. You turn the microwave on, or if you got to make a pot of coffee. So when you do it that way, you look at this critical load subpanel, you maybe only need about 5,000 watts of backup power. So it's much cheaper to get a smaller generator for that. And even solar can easily meet those critical load needs. So that's what a lot of people do, is they'll put in one of these critical load subpanels. All right. Now, if you put in a whole house backup system or a critical load subpanel that's just going to be powered by a smaller generator or solar, you have this thing called a transfer switch. And you'll have to work with your installer to see if you want an automatic transfer switch, which is automatically going to switch over to the generator or the solar backup, or if you want a manual transfer switch. So you might say, okay, power's out, go down to the service panel, flip a switch, we're on backup power. Maybe you're going to start up your generator, or at that point, your solar backup system will kick in. So that's something that you want to work out with your installer. So if you're looking at getting a whole house backup generator, here's what I suggest you do. First, find some friends that have a system like that. Get a referral to a good contractor. I have an old Generac generator. I'll talk about that in a minute. It's like over 20 years old. But Generac's one of the big manufacturers, and then there's a bunch of other good manufacturers that make these things. But it's not the equipment that's as important. It's finding a contractor that knows what they're doing. It's going to install a good system. So for the installation of a backup generator, we're talking about a gas generator, either gasoline, gallons of gas in a tank, or natural gas, you're going to need to get, for a system that's installed, a building permit. So this is for anything that's going to be powered by natural gas typically, or diesel. So you're going to get that building permit. You're going to often get a new or a larger natural gas line or natural gas meter. And so it depends on how big a generator you put in. Because if you put in a really big generator, it needs a lot of gas. And it may be that the gas line that goes to your house isn't big enough to power your own little power generating system. So you might need a bigger gas line, but the contractor will help you figure that out. Smaller gas generators usually fine with the existing gas lines. Generators almost always go outdoors on a concrete pad. They're kind of heavy. You don't want to just put them in the dirt because they're going to start sloping. So they pour a concrete pad or bring one over. And then they exhaust the fumes, the gas, away from the house. So you don't want that stuff blowing into the house. Obviously, that's why you don't put it in the garage or the basement. As far as costs for these backup generators, so to get a comparison, I've got some recent data points. My mom in New Jersey is in the process of installing a whole house backup generator. And by the way, she's the other listener to my show. She kind of shopped around, talked to friends, went to the big box stores, and found out it was kind of interesting. But the big box stores sell backup generators. But ironically, it's more expensive to buy a generator from a contractor at a big box store than from an independent company. And that's because these big box stores charge an extra 20% margin or so on the equipment and sometimes even the installation cost. So she got quotes for basically the same thing from an independent company and from a contractor selling through a big box store. Contractor selling through the big box store was a lot more money for the same thing. So here are the numbers that she got, and this is kind of fully installed with everything but the building permit. And these numbers, I think they apply kind of pretty much all over the country. About $10,000 for a 10,000 watt generator fully installed. And if you want to get a bigger generator, you can probably double the size for only another $5,000. And you can also get something that maybe 8,000 watts for, $9,000. But, $10,000 to $15,000 is going to get you pretty much what you need so that you can run the whole house, but not run everything in the whole house at once. And that's what I recommend you do. You don't want to size the generator so that you can run your gas stove, your electric stove, your electric dryer, both air conditioners, your heating system, and every toy you want to basically say, hey, I want to run the critical things. And then you can get by with a 10,000 watt or maybe even a 15,000 watt generator. That size generator is going to be fine for your heating system, your lights, your cooking, any other necessities that you have. Now, you can also, alternatively, save a bunch of money and get a much smaller gas generator. Hey, heck, you can just go to any, hardware store and pick up one of these things. Well, it might take two people to pick them up. But that's what I did about 20 years ago. I went to one of the big hardware stores and I bought a 6,000 watt, it's like a 10 horsepower, 6,000 watt gasoline generator. And I've had it for 20 years. And every year I just start it up and the thing just works great. It cost me $500 then. It's got a 240 volt outlet on it. It got a couple of 120 volt outlets on it. I keep it in my garage. And if there's ever a blackout, I wait about 10 minutes to see if it was a temporary thing. And then after about 10 minutes, I say, okay, and I got to go, get this generator so that my kids can watch TV and my wife can make a pot of coffee. And I'll drag the generator outside the garage so it's venting outside. And I'll pull the cord, start it up, run some extension cords to the critical loads, or I run a heavy-duty 240-volt cord. This is another cool thing to do, into a special outlet that's only activated if the main power's off. I'll talk about that in a minute. I wired it up, started up, generator's making a lot of noise, brrr, and then as soon as I wire it up, plug it in, adjust the circuits in the house, boom, then the utility power comes back on. It inevitably happens. But over the past 20 years, I've used it about 5 times for several hours, in one case for a day. When we had a big blackout, it was, I think January 2000 or January 2001. And it's really handy when you have that. Now, it's kind of a pain in the neck to run extension cords to everything, so the better thing to do is to put a heavy-duty cord into a special outlet that you have in the house. And this special outlet in the garage or outside the house is only connected when the power to the utility is turned off. And I could wire in a critical load subpanel, but I never did. So that's the other thing you can do. You can have the generator plug into a critical load subpanel. And an electrician probably charge you about $1,500 to put that thing in, and then it's a real easy thing to do. Now, with these portable generators and even the bigger generators, they require some maintenance. This battery backup solar systems require maintenance too, but gasoline engines are really the challenge. So I found over 20 years, here's just a little hint, keeping the carburetor dry and empty of gas is the best way to prevent gas from kind of turning into a jelly or a gumminess in that carburetor. And so what I do is I only keep a little bit of gasoline in the tank. I have a few tanks of spare gas handy that I keep in a shed. And when I want to start the generator, I put the new gas in. And then I open up this little valve, this petcock between the tank and the carburetor, and that fills the carburetor up with fresh gasoline. And then the carburetor's always got fresh gas. It starts right up, usually 2 pulls or so. And this is an old generator. When I want to turn the generator off, I don't turn the switch off. I actually close the gasoline petcock and starve it of gasoline. And what that does is it uses up the remaining gasoline that's in the carburetor, and it's empty of gas, and then you don't have this gumminess there, and think that just works great. So keep the carburetor dry, have some spare oil, because they sometimes leak oil just, automatically sitting there, and maybe get some gasoline stabilizer additives. Now, if you have a natural gas generator, the natural gas is a lot cleaner. It's not going to gum up the carburetor. That doesn't even have a carburetor. But the maintenance you might need to do there is keep the battery charged and, start the thing up every year or so, making sure that you don't have any problems. We talked a little about the power transfer switches, so you can get an automatic or manual power transfer switch. The big gas generators, the big natural gas generators, typically are going to have an automatic transfer switch. The smaller generators, you're going to have to do it manually. So, talked about gas. Now let's talk about the cool new thing, which is what people are really interested in, which is solar with battery backup. It's definitely the future. It's ideal to install, say, a 7.5 kilowatt system with a 7.5 kilowatt inverter. Maybe you have 8 or 9 kilowatts of solar panels on the roof, and then you can have a critical load subpanel that's connected to that inverter and the batteries that'll just run what you need in the house. 7.5 kilowatts, I mentioned, that's pretty good. You can get by in your house with 5,000 watts if you're kind of careful. Now, you're not going to be able to run your electric stove. You're not going to be able to run your air conditioner, but your house is going to stay warm. You're going to have hot water, and you're going to be able to cook a little bit. And the good thing about these battery backup systems is they use the same inverter that's connected to the grid. During the day, the batteries are recharged by solar, and at night or on a cloudy day when there's no utility power, you can use your battery power for as long as that battery power lasts. So here's where the sizing becomes important. There's 2 things to think about sizing. One is the power capacity, and I mentioned 7.5 kilowatts or 7.6 kilowatts is kind of a common inverter size, and that's the power the system can deliver to your critical loads, to your stove or to your coffee maker, to your TV, and to your heating system. The other thing to look at is the energy capacity. That's how much energy, how many kilowatt hours are stored in the batteries. So the more energy capacity you need, the more battery capacity you're going to need. So sometimes you might have to add extra batteries. Storing more battery power means that you're going to have power for a longer time, but it's going to cost more. So your battery backup system installer can help you with some of these trade-offs. Now, as far as the installation, you're going to need a building permit. You'll need electrical work. You're going to need a bunch of extra equipment, usually outside the house or inside the garage. The inverter, the batteries, electrical wiring boxes, disconnects. A lot of these installation things aren't really standardized yet. So there's a lot of regulations that haven't been finalized. So it's going to take some time to get this installed for you. There's more design work. There's more engineering work. There's more permitting work. The inspectors are going to scratch their heads. So it's going to cost a little bit more than regular solar. And guess what? You're going to need software. That's right. I said software. If you put in a battery backup system with solar, these inverters require some software to manage them and to control how the system's going to work with your utility, work with your solar, work with your house, and maybe even work with your car. So there's a lot of work being done in the industry about solar that's going to control battery storage systems connected to solar. Software's out there now. It works, but it's going to get better and better in the future. So let's talk a little bit about costs for these battery backup storage systems. I see articles and claims that these things only cost like $3,500. Well, in my view, that's pure and simple hype. You're not going to get a really experienced, qualified contractor to put something in for free and then maintain it. A complete battery backup system is going to cost you more like $5,000 to $10,000. It depends on the size of the system and the equipment you get. Plus, you got to add another $10,000 to $15,000 for the solar. So, if you think you're going to get it for $5,000 or $8,000 with solar, you're not going to get very much. The cool part is, if you install a battery backup system with solar, the 30% investment tax credit applies. And you also may get some state and local rebates. So here's my advice. If you're worried about a power failure, get a small gasoline engine or a dual fuel generator. Runs off propane that you use for your gas grill or a tank of gas. It's going to cost you $500 to $1,000. If you want something automatic and bigger, get a whole house generator powered by natural gas. That's $10,000. It's a big number. And if you want a solar power backup system, there are a few that are available, but they're expensive. One company in Silicon Valley is called Adera. They used to be JuiceBox. They've got a pretty good system now. And then SolarEdge and Enphase are also coming out with new new integrated battery storage systems with cheaper batteries. So, those are some good companies to look at. My suggestion, if you're not in a hurry, wait a year or two for solar backup system prices to come down and for systems to get a lot more reliable. All right, that's all the time we have on this week's Energy Show. Thanks to all of our listeners for tuning in. And if you missed any of today's show, you can go to our website at cinnamonsolar.com and listen to the podcasts.
So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.